Ever wondered how a microwave heats your food so quickly? This everyday appliance, nestled in our kitchens, is a marvel of modern technology, and yet its operation remains a mystery to many. Let's unravel this enigma together. You've probably noticed that microwaves heat food far quicker than a conventional oven. One moment, you're placing a bowl of soup inside, and in less than 2 minutes, it's piping hot and ready to serve. But how does this happen? How does a microwave turn cold leftovers into a hot meal in just a blink of an eye? Here's where the magic happens. Or should we say, science? Microwaves use something called electromagnetic waves, a form of energy that's around us all the time, though we can't see it. These waves are incredibly fast and energetic. They're the same waves that bring your favorite radio station to your car's stereo, or that allow your cell phone to connect to the internet. In the case of a microwave, these waves are tuned to a very specific frequency, one that causes water molecules in your food to vibrate. This might sound strange, but it's similar to how you might start to sway when your favorite song comes on. These vibrations generate heat through friction, much like how rubbing your hands together on a cold day warms them up. So your microwave isn't just cooking your food, it's causing a molecular dance party, where the water molecules in your food are the dancers, and the electromagnetic waves are the music. The faster the dance, the hotter the food gets. But don't worry, this dance is perfectly safe. The waves are contained within the microwave and won't escape to cause any harm. It's a controlled scientific process that's been tested and refined over many decades. So next time you're warming up a cup of coffee or cooking a quick meal, remember the intricate ballet of molecules happening inside your microwave. And remember, it's not magic that heats your food in minutes, it's science. So, it's not just magic, it's science. It's time to unravel the science behind the magic of microwaves. Microwaves, the kitchen appliance we all know and love, operate on the principles of electromagnetism. But what does that mean? Well, at the heart of every microwave is a device called a magnetron. This magnetron produces electromagnetic waves, specifically microwaves, hence the name. These microwaves are a type of electromagnetic wave that fits right between radio waves and infrared radiation on the electromagnetic spectrum. They have a wavelength of around 1 millimeter to 1 meter and a frequency of about 1 billion to 100 billion cycles per second. Now, here's where the magic happens. These microwaves produced by the magnetron pass into the cavity of the microwave where your food is placed. As these waves penetrate the food, they cause the water molecules in the food to vibrate. Imagine a crowded dance floor where everyone is moving to the rhythm of the music. That's what's happening at a molecular level inside your food. The microwaves cause the water molecules to move back and forth rapidly, creating a friction between the molecules. This friction generates heat, and voila, your food gets warmed up. But why water molecules? Well, water molecules are polar, meaning they have a positive charge at one end and a negative charge at the other. Microwaves are also polar, so when they encounter water molecules, they cause them to rotate and vibrate, leading to the generation of heat. This process is a demonstration of the wave-particle duality principle. The microwaves exhibit both wave-like and particle-like properties, allowing them to interact with the water molecules in the food and produce heat. In essence, the microwave is a marvel of electromagnetic technology. It uses the principles of electromagnetism and wave-particle duality to efficiently heat our food, making our lives just a bit easier and our meals a bit quicker. Isn't it fascinating how science is at work in our everyday appliances? Ever peeked into a microwave and wondered what each part does? Well, let's demystify the inner workings of this everyday appliance. The heart of the microwave, the component that actually generates the microwaves, is the magnetron. It's a high-powered vacuum tube that works by sending an electric current through a magnet field. This interaction generates microwaves, which are then sent into the cooking compartment of the microwave via a channel called a waveguide. The waveguide is like a bridge connecting the magnetron to the cooking compartment. It's specifically designed to contain and direct the microwaves safely into the oven. Without this vital component, the microwaves would scatter aimlessly, making the appliance ineffective and potentially hazardous. Once the microwaves are in the cooking compartment, it's time for the turntable to do its job. This rotating platform ensures that the food is heated evenly. As the microwaves bounce around inside the compartment, the turntable spins, making sure that every part of your meal gets equal exposure to the microwaves. It's like the sunbather rotating their lounge chair to get an even tan. The final piece of the puzzle is the control panel. This is where you, the user, come into the equation. The control panel allows you to set the cooking time, power level, and other settings. When you press Start, the control panel sends a signal to the magnetron to start generating microwaves. It's the command center of the operation, ensuring that your popcorn pops perfectly and your leftovers heat up just right. Each of these components plays a crucial role in the microwave's operation, working together in a symphony of science and engineering. The magnetron generates the microwaves, the waveguide directs them, the turntable ensures even heating, and the control panel provides user control. So the next time you use a microwave, you'll know exactly what's happening inside. Like everything else, microwaves have their advantages and disadvantages. Let's delve into both sides of the coin to better understand this ubiquitous kitchen device. Firstly, the advantages. The most apparent one is speed. A microwave can heat your food in a fraction of the time that a conventional oven or stove would take. This speed is a godsend in our fast-paced lifestyle where every minute counts. Another benefit is convenience. With a microwave, you can cook a variety of meals at the push of a button. From popcorn for movie night to a full dinner plate, the microwave simplifies the cooking process. It's like having your personal chef ready at your command. Energy efficiency is another plus point. Microwaves use less energy than traditional ovens because they heat only the food, not the entire oven. This not only saves on your energy bill, but is also a small step towards a greener planet. Now let's consider the disadvantages. The first drawback that comes to mind is uneven heating. We've all experienced that hot exterior and cold interior of a microwaved meal. This is because microwaves heat food by vibrating water molecules, and if the water isn't evenly distributed, neither is the heat. The second disadvantage is the inability to brown or crisp food. If you're a fan of that golden crust on your lasagna or the crispy skin on your roast chicken, a microwave might disappoint you. The science behind this is simple. Browning, also known as the Maillard reaction, requires temperatures that a microwave just can't reach. Lastly, microwaves have been criticized for nutrient loss in food. However, it's important to note that any form of cooking can lead to nutrient loss, and microwaving is no exception. The key is to use minimal water and heat food for the shortest time possible. While microwaves may have their limitations, their benefits often outweigh their drawbacks. They've become an integral part of our kitchens for their speed, convenience, and energy efficiency. As with any tool, knowing its strengths and weaknesses can help us use it more effectively. Science isn't just in the lab, it's all around us. This statement rings true, especially when we consider the humble microwave. It's a perfect example of how deeply science is ingrained in our everyday life, and how understanding it can elevate our appreciation for the world around us. The microwave, a common household appliance, is a marvel of scientific ingenuity. It uses the principles of electromagnetism and wave-particle duality to heat our food efficiently. The electromagnetic waves it produces cause water molecules in our food to vibrate rapidly, generating heat through friction. This process, simple as it may seem, is a testament to the power and elegance of scientific principles at work. But the microwave is just one example. Look around you. The light bulb illuminating your room is a product of our understanding of electricity and light. The smartphone in your hand is a testament to advances in computing and telecommunications. The car you drive utilizes principles of thermodynamics and mechanical engineering. The list goes on and on. Every object, every process, every convenience we enjoy is steeped in science. It's not just about experiments in labs or complex theories. It's about the application of these principles to make our lives better, easier, and more fulfilling. It's about the curiosity and creativity of countless individuals who looked at the world, asked questions, and sought answers. So the next time you heat up a meal in your microwave, take a moment to marvel at the scientific wonders at play. And don't stop there. Look at the world around you with a sense of wonder and curiosity. Explore. Ask questions, seek answers. You will find that science is not just a subject, it's a way of understanding and appreciating the world. Remember, every day brings new opportunities to discover the magic of science in the world around you.